So here we are, another episode of Chargeheads UK with me, Tim, and Peter Melville from HEVRA. So I thought it would be a really good idea to do a video just to give people more of an idea and understanding about EVs and a bit more information specifically around battery longevity and fixing batteries. Those have seen one of my episodes before where I didn't know where to MOT my car, and I used a HEVRA garage, so I'm going to put that at the top of the screen for people to check out. HEVRA is a hybrid and electric vehicle repair alliance.
Correct.
Perfect. Yeah. And you guys, yes, you do hybrids, disgusting things, but also electric, and that's what we're going to focus on today. So servicing and repairs, is that right?
Yeah, that's it, servicing and repairs. And just to touch on the hybrids, because I must admit, I'm not personally the biggest fan of hybrids, but the reason we cover hybrids is because there are technological similarities. So from a garage point of view, it's working on a hybrid is a good way of practicing, for want of a better word, gaining experience and getting some return on investment. And the other reason we think it's important to support hybrids is because if somebody buys a hybrid and nobody can fix it, that person is going to be put off them buying an electric car because they're going to perceive that to be related. So we hope that by providing support to hybrids in the long term, we're going to turn more people onto electric.
Yeah, and for a lot of people, it's a stepping stone, or as I like to call it, a gateway drug. But everyone's got their own thoughts on it at the end of the day. But yeah, so just to confirm, you guys have been going since 2017, is that right?
That's right. Yep.
Yeah. And how did it all come about?
It starts with me, really. So my background is going to garages, fixing awkward electrical faults, basically. And I've done a couple of other things as well, but that's sort of what I spent the majority of my career doing. And because of that, I sort of know garages, I know what goes on in garages and stuff like that. Then when I bought an electric car myself back in 2015, I was then an EV owner as well. So I was then speaking to other EV owners, and I sort of had a foot in both camps, for want of a better term. And I could sort of foresee a potential issue that garages would struggle to repair electric cars, and that would create a problem for the garages because they would sort of gradually run out of work as electric became the norm. Yeah. And it would also become a problem for EV drivers because they would have a car that might have something wrong with it and people wouldn't be able to fix. So I thought, well, something needs to be done and no one else is doing anything, so perhaps I should do something.
No, absolutely. And coming from a main dealer background of, goodness me, 20 odd years after getting into the DC charging, of course, now, but I did see it firsthand that it to me, a couple of years ago, I saw that a HEVRA garage was more advanced in terms of their knowledge than any of the main dealers in a lot of cases. Don't get me wrong, there are specific main dealers, certainly in the group that I work with, which were slightly better, but yeah, the understanding was pretty poor, to be fair. But yeah, I mean, what does HEVRA do in the main to EVs? Is it servicing, repair? I mean, what are the kind of common things that you guys get asked about?
Yeah, that's it. It's servicing, it's repairs on the mechanical side, so suspension, brake, steering, all that sort of stuff. It's also repairs on the EV specific systems, so battery, the motor, inverter, charger, all that sort of stuff. The way it works is all of the garages that are HEVRA members, they all receive a regular newsletter from us. They receive all of our documentation, and they can also contact us for technical support. So let's say, for example, you worked in a garage, you go on a training course and you learn about electric cars, and on the training course they might have Nissan Leaf or whatever, and you learn about it and you get your certificate and everything else. You go back to work and someone pulls up in a Jaguar I-Pace. Now that vehicle is quite different to the one you did your training on, and that's when you can sort of refer to our documentation for what you need to know about that car.
Right.
And then if they're still struggling, they can get in touch with our support team and say, look, I've got this vehicle that's got this particular issue. I've checked this, I'm not really sure what to do next, or do you think this is right, or whatever, and then, you know, we can go to and fro.
Oh, great.
And and the way it sort of works from there is once we've sort of gone backwards and forwards with that garage to get to the bottom of that fault, we can then sort of share that experience across the network, so that effectively the experience of one garage is the experience of all the garages, if you like, because of the way it's sort of shared. So hopefully it's really accelerating the skill set out there, and in the long term leading to EV adoption.
So everyone kind of learns together in a way in the HEVRA family. Are you the godfather, Pete? Yes. Are you the godfather? The EV godfather? Yeah. So, you know, in terms of EVs, I mean, we've got EVs now that have been around since 2011. So more and more EVs, potentially high mileage, potentially, you know, batteries that are degraded slightly more. What tends to be the most common issue of an EV not working you found so far?
Probably. So we don't necessarily see a representative sample, because we only know the things that garages need our help with.
Sure. So
there could
just
be
a gauge, Pete. I'm not holding you to the definitive statistics for the whole UK, but
but probably the two most common symptoms on the sort of EV specific side is probably the heater not working and when you plug the car and it doesn't charge. They're probably the most common two things that we do see.
Okay, interested about the plug it in not charge, because when I was looking for a cheap EV, I think I came across a Renault Zoe that was having issues. Is that quite a common thing on the Zoes, or is there a particular car that stands out for having charging issues?
Yeah, it can be. Yeah, the Zoe charging system is more complex than most other electric vehicles.
Right.
And one of the benefits of it is that you can buy lots of the parts of the charging system separately.
Okay.
So, whereas on most cars, if you were to buy it from a dealership, it would come as sort of one unit that was quite expensive. On the Zoe, you can sort of buy individual bits that are less expensive. But of course, it then requires a bit more expertise to work out which bit it is, because you're not just replacing everything. So.
Yeah. No, fair enough. And going straight into, again, what I wanted to focus on was the battery side of things. So time and time again, when I'm recommending, hopefully not preaching, recommending EVs to people, a lot of common arguments or worries for people is battery longevity, and also the battery, you know, if it goes wrong, I need a new battery, it's going to be X amount. Just to focus on the, you know, longevity. I mean, I've seen quite a few examples recently. I think Quentin Wilson did post something about 360,000 mile Tesla Model 3. And then James and Kate from the Cleverly team did recently do a video about an over 200,000, again, Tesla Model 3 long range. And I've certainly heard and seen Nissan Leafs that have done over 100,000. What's your experience on longevity of EVs?
Some things are still an unknown, if I'm honest, because the cars that are being sold new now are not the same as the cars that are already 10 years old.
Yeah.
But in general, we believe that longevity will get better, and I'll come back to that in a moment, and I'll explain the reasons why. Looking at the cars that are sort of old enough to sort of see issues, you can sort of put battery-related things into two categories. So on the first category, you've got a fault, where your car might be working perfectly one day, it's still, you know, gets a good range and everything else, and all of a sudden you get in it and it doesn't work. And then on the other side, you'll get degradation where the battery still works, but obviously over a period of time, you'll find that it sort of gradually loses capacity. Both of those things, I would say, it does depend on the vehicle.
Yeah.
Faults with the battery, generally we can repair. So it's a bit like saying, you know, I've got a petrol or diesel car and I've got a problem with the engine, therefore I need a new engine, which we all know that isn't the case. You would generally replace the part of the engine that had gone wrong.
Although that does tend to be a main dealer trait, and this is what, and I don't know if you agree with this, it tends to be the kind of, the rod has got, or the piston's gone, or the valve's gone. They put in a new engine on warranty, generally speaking, but you have to take it to a independent garage just to, fix that original engine. And I think it's kind of similar with the EVs in that respect. But sorry, carry on.
Yeah, no, I think you raise a valid point. It does depend where you go, and certainly on the warranty, the manufacturer will have the mindset. We don't know the skill set of the guys that are in that dealership in that particular town or city. Therefore, we're not going to take the risk. We're going to say, just fit an engine, and then we know that you can't do it wrong, basically. In an independent garage, the boss of the garage will say, right, we need to repair this engine. I'm going to give it to that particular guy because I know that he can do a good job of it. And it's the same we're seeing with EVs. In that independent setting, the boss of the garage knows the skill set of the different people in the garage and can say, look, this person in the garage can do that particular job and do it well. And therefore you have sort of a wider range of possible repairs.
Yeah.
So in terms of faults with the battery, because inside the battery pack, it's not just cells. You've also got, for example, temperature sensors. You've got contactors, which are like electrical switches that can sort of disconnect the battery when the car's not in use.
Yeah.
And you've got little circuit boards that will measure the current and the voltage of the various cells in the battery pack and stuff like that. And sometimes we see little issues with things like that. Generally, they're repairable. So it's a case of taking the battery out of the car, opening up the battery, doing whatever testing is necessary to find the problem, replacing or repairing whatever parts have failed, putting it back together, sealing it, making sure the sealing is correct on the battery, and then putting it back in the car. So it's, we need to come away from this sort of idea that if you get in the fault in the battery, you need to replace the entire battery as one unit, because that's quite simply not the case. And we're proving it because we're fixing these things.
Yeah.
On the degradation front, degradation is certainly not as fast as people thought it would be when EVs first came about. They sort of said, you need a new battery every 3 years. And then once several cars were over 3 years old, they sort of said, you need a new battery after 5 years. And then they sort of pushed it back to 10 years. And we've now got cars that are 10 years old and still work. So, after 10 years, you do often see some noticeable degradation. But what we're generally finding is that if you get, for example, one cell in a pack that's failed or has degraded particularly badly, then generally, we can replace that cell, and the pack won't necessarily be as good as new, but it will be as good as the remainder of the cells.
Yeah.
And you'll see a massive improvement there if you've got one that's really bad. If all of the cells have degraded a little bit, which we do see because obviously they're all the same age, done the same amount of work, then generally speaking, people just use the car for something different. So if that was your main car 10 years ago, you might decide that that's now your sort of, taking the kids to school, leaving at the station sort of car, or whatever it might be. But, there's still a huge market out there for cars that just nip about locally. And I think they're serving that purpose, to be honest, in the cases where it might not be necessarily viable to replace or repair the battery. But I would say that degradation is much less and coming much later than people first thought when it came about. The other really important thing about degradation is we see more degradation on some makes and models than we do with others.
Yeah.
And there are a few different reasons for this. So the first reason, I believe, is to do with temperature control. There's a few different methods of controlling the temperature of the batteries. Some batteries don't have any cooling system whatsoever. So Nissan and some of the early Volkswagen, Peugeot, Citroen cars were in that category. And there were software controls in place so that if the battery got too hot, it would sort of limit the performance and perhaps limit the charging speed and things like that. So,
yeah.
But cars that don't have any cooling do seem to degrade a little bit more quickly than cars that have cooling systems.
Sure.
We've then seen some other types of cooling. We've had air conditioning, refrigerant cooling, and liquid cooling. And all the manufacturers gradually seem to be converging around a system where the battery pack is liquid cooled, but it also has a heat exchanger with the refrigerant system. So you actually use water, or it's water and glycol, to cool the cells in the battery pack. But if necessary, you can use the car's air conditioning to cool the water.
Okay.
And the reason a lot of them are going for that sort of system is because if you imagine you're using the car in a place that's really hot, not here in the UK necessarily, but
not at the moment, that's for sure.
Yeah. But if you imagine you're using that vehicle in a country where it might be 40 or 50 degrees C, then if that liquid cooling system was 100% efficient, the coolest you could get the battery would be ambient temperature. Whereas by using the refrigerant, you can actually have an ambient temperature of perhaps 40 degrees, but bring the battery down to a more comfortable temperature of, say, 25 degrees, where it's going to improve its longevity.
Okay, that's really interesting.
Yeah, and we've seen that if I pick a few manufacturers, so for example, Kia used to use air cooling on their batteries.
Oh, like the old Souls with shadow mode charging.
Yeah,
okay.
That's it. They've changed to refrigerant. They've changed to liquid cooling, I should say.
Yeah.
BMW used to use refrigerant cooling. They now use liquid cooling. Virtually all of them that used to use air cooling have done away with it. And that's, I believe that's partly because if you want to have air cooling, you need to have air space in the battery.
Yeah.
And if you want to fit as much capacity in as possible, you can actually save space by having a better cooling system, and then you don't have to leave room for the air to get round.
Yeah.
Now, the reason it's interesting that a lot of manufacturers are converging on this liquid cooling of the battery is those are the cells that have lasted the best. So if we look at cars such as the Vauxhall Ampere, the Tesla Model S, they were amongst the first to use this type of cooling system. They're now over 10 years old in some cases, and the degradation has been minimal.
Do you know what? It's really interesting because probably the Ampere is the EV I know least about. I've never really considered it. Is that the diamond in the rough? I was thinking because obviously the older Nissan Leaf and all the Nissan Leafs are air cooled. Am I right?
No, they're not cooled at all.
No, yeah, that's right.
Yeah. So
not cool.
Every Leaf made up until now of all battery capacities and all variants doesn't have a cooling.
Which is astonishing based on especially the last few years. It's quite common knowledge that uncooled batteries are going to have the degradation. But I mean, what was the Mitsubishi Maev and the Citroen C0 and stuff? Were they the same?
No, they were air cooled.
Right.
Similar to the Kia Soul, it takes air from inside the car.
Yeah.
And then it blows it through the battery and out the back. That's the system that's been sort of done away with. You can also get other issues, like you can end up filling the battery up with dust and stuff like that if you're someone that doesn't keep the inside of your car very clean. But
wow.
A common issue, but I think these are the reasons that some manufacturers have moved away from the cooling systems.
No, that's really, really interesting. So no, thank you for that, because these sort of things, they play on my mind at night. Believe it or not, Pierre.
Well, the other thing I just wanted to say about degradation.
Yeah, far away.
Is if you imagine for a minute two different cars. So you imagine on one hand you've got a Volkswagen e-Golf, and on the other hand you've got a Volkswagen Golf GTE. So they're the same car, but one of them is a plug-in hybrid, and the other one's fully electric.
Yeah.
And the fully electric has a much bigger battery. If you're driving both of those cars at 30 miles an hour down the road, the GTE, the hybrid, the battery is working really hard because it's a much smaller battery doing the same amount of work. It's having to, it's like a hamster pulling a horse and cart, if you like. Whereas if you imagine the e-Golf, you've got a really big battery, and it's finding it quite easy really to do the same amount of work.
Does it have to put out the same ampage and voltage, but obviously
yes. So we're putting out the same amps, but from a much smaller battery.
Yeah.
So when we talk about battery discharge, we talk about something called the C rate, which is the discharge rate compared to the capacity of the pack. And the discharge rate when you're driving at 30 miles an hour, the actual discharge is the same, but when you compare it to the pack size, the hybrid is having to work a lot harder than the electric vehicle.
Yeah.
And of course, what we've seen over the past 10 years is batteries have got a lot bigger, and therefore to do the same, if you're driving at 30 miles an hour, 60 miles an hour, whatever, you're then coming home, plugging it into your house and charging it at 7 kilowatts. If the battery's twice the size, it's working half as hard.
Yeah, I get it.
So, and of course, the other thing is that's perhaps more obvious is if you start off with a car that does 200 miles, if that loses 10% of that, then that's still a good car for the vast majority of people. Whereas if you start off with a car that's only got 60 miles and you lose sort of 10-20% of it, then it's getting into a bit of a niche market where it's not perhaps that usable.
I would love to test the state of health on my Tesla battery, because I bought the Tesla Model 3, I think it was March last year, with 56,000 miles on it, long range, and I've never had it show more than 286 on 100%. Obviously, there's lots of tips out there, everybody, with regards to longevity of battery, whether it's keeping it between your 20% and 80%, making sure you don't do as much DC charging, and I'm sure there are lots of other ways you can increase the life of your battery, but that's not what this episode's about. But yeah, now with 81,000 miles, it doesn't seem to have changed at all. And I know the Teslas are quite good, but one question I had about the battery replacement, the Tesla Model 3 is quite different, isn't it? It's quite difficult to change or fix batteries in those. Am I right in thinking that?
Yes. So what they do as a sort of non-technical thing is they join all the cells together as per any other battery pack, and then they basically sort of cover it in glue, and of course that makes it more difficult to repair. But the Model 3 is not something that we're repairing batteries in any number at the moment, just because of the age of the car. They're not really failing if and when they do.
Have you guys actually made some repairs on Model 3 batteries then?
No. So I think we've seen one issue on a Model 3 battery that went back to Tesla and got sorted under warranty.
Yeah.
And that's going to be a challenge to work out how they can be repaired. But there are so many things that now we do as part of our everyday work that years ago we thought were impossible.
Yeah.
So I think, when the time comes, we didn't used to be able to repair the Tesla Model S and X batteries. We can now repair those.
Yeah. That's great news.
A lot of the sort of circuit board repairs and diagnostic methods and stuff like that we've developed over the years, they used to be impossible, and now we just sort of do them on a daily basis and we don't think anything of it, sort of thing. So I think by the time, if and when they start failing, we will hopefully have developed some sort of solution.
Well, Peter, we've got 39,000 miles to go, so the clock is ticking, okay? I'm not saying it's going to, combust or break as soon as the 120,000 mark has gone, but quite a lot of people have told me that it will. In fact, they're surprised it hasn't already. Many EV naysayers when I say that an EV will last forever. So obviously Elon will be pressing the button out of warranty. He needs to buy a new one. The button will be pressed, and I'll be at your door, Pete. So there we go. So no, that's great to hear about the batteries and longevity of the EV side of things. Are there any other things that you would like to discuss before we start talking about Little bit about the future, about HEVRA, what's potentially coming, what is going to happen in the next few years, what you guys have got planned, and just to find out a little bit more about your preference in EVs and what you're driving.
Yeah, I can do. So I'd just like to mention something about what we call power electronics, which is the sort of general term we give to all the high power electronic components that make the car work. So obviously we need an inverter to drive the motor, we need a charger to convert the mains power into suitable power for the battery.
Yep, AC to DC, of course, yep.
That's it. And obviously we need to provide power to low voltage systems and stuff like that as well. So all of this stuff sort of comes under the umbrella of power electronics. And power electronics doesn't degrade, it just works, and then if you're unlucky and the car's a bit old, then perhaps it might stop working, generally without very much notice at all.
Right.
And I just wanted to hopefully reassure people that this sort of thing is quite a big focus for us. So this is part of a Kia Soul EV that we've been doing some investigation on at the moment. We've got a few of those in various states of disrepair and undergoing some tests and bits and pieces, working out some repairs on those.
Yeah.
And yeah, it's we don't have like a set range of things that we can repair. Basically, if an electric car comes in and it's got something wrong with it, then if it's not something we can already fix, then we will do our best to develop a fix. And obviously, if you're the first person that's ever had that particular fault, then your car might not be fixed quite as quickly as people subsequently. But, and, you know, I'm not going to say that we can repair absolutely everything on every single car, but we'll give it our best shot, and most things we can come up with some sort of solution.
No, brilliant. I've just thought of it, just before we go on to the future of HEVRA. Very quick. It's like a quick fire round rather. I know what car I would buy, what EV I'd buy if I had 10 grand. I would probably go out and buy a Hyundai Ioniq because it's got CCS charging, it's efficient, reliable, good range, and yeah, that's what I would buy. However, I struggle to think what car I would buy at the sort of £5,000 to £6,000. What would you buy, Pete?
I think the sort of default option in that sort of price bracket is perhaps something like a Zoe.
Yeah.
And you know, with a Zoe, the batteries we haven't seen excessive degradation on particularly.
Yeah.
The batteries have held up better than most EVs of that era, if you like.
Yeah.
We get some issues with some of the electronics and stuff like that, but they're all fixable. The only downside of the Zoe is, of course, you've only got AC charging. So
yeah. And it's about last time I looked, £8,000 for the for a 40 kilowatt hour battery pack, which is still AC, and then the CCS ones aren't till about 10 grand, whereas you'd probably buy a Hyundai Ioniq. Although there's quite a few coming down, like in price, whether it's MGs and yeah, a whole raft of other things. I think 15 grand. There's a whole load of EVs now that you can choose from for sure. But
yeah. And you know, the Nissan Leaf is also in that sort of lower price category. The benefit of the Leaf over the Zoe is, of course, you've got the CHAdeMO DC rapid charging, which I wouldn't recommend an old Leaf like that if you're sort of doing hundreds of miles every day. But if you want a car that you're going to drive around locally, but every now and then you do a long journey, then having a small battery but fast charging at least gives you that option.
And this leads me nicely on to what EV that you drive, Pete.
Well, I have a very specific set of needs. I actually have a Renault Zoe van.
The Renault Zoe, I've seen your Renault Zoe van, so I've seen it in person. Is it the same one, or has it been upgraded recently?
No, it's the same one. Yeah, it still does everything I need. And the reason I have the Zoe van, this is the most important thing, I would say, if you're looking to buy an electric car or any car, is that basically it has to suit your needs. And I have quite a specific requirement in that I spend quite a lot of time in places. I do an awful lot of destination charging,
Right, I see. Okay, so you're going to start saying AC, aren't you?
Yes.
Yeah.
Yes.
Yes.
So, yeah, most places where I go, or quite a lot of places where I go, I can get 22 kilowatts AC, which means without using a rapid charger, I can fully charge my Zoe in about 3 hours, and that gives me another 200 miles.
And I hasten to add, there's only about 5 cars exist that have 22 kilowatt AC charging. Just before anyone gets excited, 22 kilowatt AC charging, there's only about 5 cars, just to clarify that. I think, what are they? Nissan Leaf, the Aria maybe?
The Leaf doesn't have 22
Not
kilowatts.
the Leaf, sorry.
No, the Aria has 22 as an option. I think it might be standard if you get the larger battery version.
i3, is it? i3?
No, the i3 is maximum 11, and even that's an option. There was a couple of variations.
I'm going to get schooled now here, Pete. Come on.
There's a couple of variations of the smart car that had 22 kilowatt charging.
Okay.
And so did the Tesla Model S and X, but again as an option. So it's sort of ironic with the Zoe. It was probably the cheapest electric car around for most of the time it's been on sale, and also the fastest charging on AC. So the fast charging on AC is a big bonus for me. It also has DC charging. Now, the DC charging on the Zoe is not very fast, but...
Was it like 50, something like that?
It's a maximum of 125 amps, which is about 45, 46 kilowatts.
Yeah.
Generally speaking, depending on circumstances and stuff, it's more like 30-something kilowatts most of the time.
Mm-hmm.
But, so, if you're someone that's going to be going up and down the motorway rapid charging all the time, it's probably not the best option.
No.
But if you're someone that wants to stop on the motorway sometimes but spends a lot of time destination charging, then it's quite handy. And also because I drive around with test equipment and things, I need a van, but I don't need a very big van like a Vito or something like that. So the Zoe is quite good. And of course, although it's only a tiny little van, it still counts as a van for company car tax purposes. And I don't know if anyone knows this, but if you have a fully electric van, you don't pay any company car tax at all. So you do on an electric company car.
Yeah, it's like 2% now, isn't it?
Yeah, and you do if you have a diesel company van, but if you have an electric company van, you don't pay any company car tax at all. So
that's a nice little nugget there. Thank you, Peter. And what would be the dream EV if money no option? Your everyday car. What would be the preference?
I'm quite drawn to the Porsche Taycan, I must admit. That's I quite like the look of that. Another little favourite of mine, and I used to have one actually, is the BMW i3. I think they're quite a fun little car.
I've grown to love them because I love the inside of them. Yeah.
I loved the doors in the showroom, and then I didn't really like them once I owned it, if I'm honest. But I still have a little soft spot for them, and I quite like the Mini as well, which is sort of vaguely i3 related.
Yeah. No, I've not driven the Mini. I do fancy having a go in the Mazda. I do like the Mazda MX. Is it MX-30?
Yeah.
Obviously, the range is absolute dog poo, but it's one of them. Rimac. I've actually got some Rimac sunglasses. They're in my car. I was really happy to manage to get some of those off the Rimac stand at Goodwood Festival of Speed, I must admit. Obviously, my dream EV is the one I'm building. But if you were to be able to build an EV converted, old school car, what would you convert, Pete?
Now that's a good question. I don't know. I might do a big old 80s Mercedes or something like that.
Get all the family in.
Yeah, I might go a bit older and have something like a Citroen Traction Avant or something like that. Just to stand out a bit. But I've not really considered it, so you sort of put me on the spot there.
Well, that's what I do. That's what I do. And any kind of future plans for HEVRA at the moment, Pete?
To be honest, and it would have been the same if you'd asked me back in sort of 2017. Just more of the same, to be honest. So
every day's a new day, right?
Yeah, exactly. We're supporting new vehicles as they come out. We're learning about the new models that are being sold, which we'll be fixing years down the line. and we're learning about new fixes and repair methods for the models that are already out there. And the only thing is that is exciting is we're trying to sort of build it up outside the UK. So
wow, cool.
We're pretty well established in the UK. I feel that we've set it up in order to avoid this potential issue of both for garages and for EV owners. And we get people asking from overseas if they can sign up, which we sort of allow them to, and we thought, well, perhaps we'll make it a bit more official and and sort of push it a bit more in other countries as well. So
no, that sounds great. And any garages or any people that want to get their vehicle serviced at a HEVRA specialist garage, it's just a question of visiting hevra.co.uk, isn't it, pretty much?
hevra.org.uk is the website, but
oops, I'll put that at the bottom. Make sure you don't get confused. And while I'm at it, don't forget, Pete, if any of these garages are asking for DC chargers, you know where to come, of course.
I do indeed. Yep.
Tim at Vital EV, don't forget about me now. But no, it's been really, really insightful. I've definitely learned something. I've learned quite a few things actually about what you guys do. So really, really appreciate spending the time. For me and the Chargeheads and anyone else watching the channel wants to know more about electric cars. So thank you very much, and hopefully I'll see you at a show soon.
Cool.
Good man. All right. Cheers, mate.
Cheers.